Okay, this is how to make a talking chatbot. So, part one, the audio component. What we've got is we've got a module called Pi Audio, which I downloaded that one and used dpackage to install it. So first of all, we'll make a component that can record some audio as a WAV file and then save it, and that will be the input for our talking chatbot. But first of all, we'll just look at the audio component. The audio component lives in this file, which imports Pi Audio and imports a module wave. So these are the setup constants for the Pi Audio. Chunk size, format, that's a 16-bit, one channel mono, 16 kilobit sample rate, and it's going to record for 4 seconds here. This code creates a file name, invokes Pi Audio, records, puts it into one WAV, and saves the WAV. So let's just run that, which will be done. Whoops, not very clear, is it? Let's run that, and you'll see what it does. So here we go. Hello, testing. This is a test. Okay, so that's recorded something. The little recording it's made is here. So let's play it and just check that it worked. Hello, testing. This is a test. Okay, fantastic. That's worked. Right, that's the first component. How to record some speech. So there we go. Next is going to be feeding that speech recording, little WAV file, uncompressed audio, into Python Pocket Sphinx. Okay, and we've got some code to do that, the separate module, which is called this one. And so it looks like this. These three constants are the paths to the Markov model, the Markov model there, and WSJ stands for Wall Street Journal because that was trained on a large corpus of speech from the Wall Street Journal. The language model here, which again is called WSJ, so that was also part of the situation. It's a table of what syllables are likely to follow what other syllables, and this is a dictionary which identifies all the words that Sphinx can recognize and their pronunciations. So we make a function here, and that invokes Sphinx and Sphinx base, pass it the WAV file, and then decodes it into a string, which is its probabilistic guess as to what the speech was actually saying, and then we'll just print that out on the screen. So there's the code for that. And again, I'll go to a terminal and invoke it, and we'll see what happens. Okay, hang on. Right, so we want to do Python svin.py. Here's all the output as it chews up that little WAV file, and this capitalized text is its interpretation of what I said. So it got the word testing right, but that's about it. Okay, fair enough. We're not operating on fantastic accuracy at the moment. For that, you'd have to train Sphinx yourself, but this is just proof of concept, so we've got at least an interpretation coming in without any bugs. So that's that part. Right. Now what we're going to do, so we've had the audio component, and we've had the speech recognition component, and now we've got the AML chatbot component. So AML chatbot is a Python script that invokes the module called PyAML, which is there. So you download that and run python setup.py install, and I've done that earlier. And here's a very, very simple AML brain, which I've called wildcard.aiml. And whoops, it's having it in the wrong mode. So I'll open that with a text editor. There we go. And so this is the header of the file, which defines the dialect of XML that you were using, which is AIML. And here we have some tags, some elements, some tags. The pattern element represents what the chatbot gets as input, and the template element represents what the chatbot gives out as a response. And that is your AML. That's the most basic approach to it. AML can do some other things, but again, we're not going to go too much into that. So what I've done with this file of the chatbot brain is to create a hell of a lot of wildcards because the speech input from Sphinx is so inaccurate that it's very hard to get a proper match. But at least we'll get our talking chatbot. So there's your AML brain, and here's a tiny little script that just imports PyAML, opens an AML kernel, feeds it a raw input from the keyboard, and puts a reply. So we'll just run that, and you'll see how that functions. Okie doke. Right, what's it called? Python chat. Python chat.py. Here it is. There's the prompt. There's the prompt for the text input. So I'll just say hello, and it will say something back. Hello, tell me your name again. I've forgotten. Okay, so we've done that. That works. Right. There's one more component, and that's the text-to-speech. Text-to-speech is really easy on my Ubuntu system because eSpeak is already installed. So we just say, eSpeak, hello, this is a test.
Hello, this is a test.
Okay, that's working. So, final stage, we've done the text-to-speech. Final stage, integrating it all into a talking chatbot. So, let's give it a go. Right. So again, to recap, the code is all being put into one script, which is called talktome.py. Here we go. Import all the required modules, the audio, the wave, the AML. We import Sphinx in this function. Set up Sphinx, set up a decoder, set up audio, set up recording. That's all the recording. Feed the recording to the speech recognizer, get the response of what it thinks you've said, which is this line here. No, it's not. Sorry, it's that line. And then feed the recognized string into the AML chatbot, which is that line, and then feed the output of the chatbot to eSpeak, which is there, and then execute the function in a shell. Okay, so let's try it. Right, where are we? No. Okay, so if I just go here, boom, 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 Python talk to me.py, let's see what it's like to talk to a chatbot. Let's hope, fingers crossed. Hello chatbot, how are you doing?
What is the meaning of life?
What is the meaning of life? I'm not sure.
I love you.
Ah, well that's a very touching little meaning, thank you.
Do you believe in God?
I'm not sure actually.
Keep talking, at least I am listening.
Well, thanks for listening. I think that's enough to demonstrate that you work.
Say more.
Well, that's all, viewers. So we've done that, and I'll put the code up on my blog. And
Am I sexy?
No, shut up. Come on, this is confusing me. Okay, there you go. So there we have it. Thank you very much, viewers.